Welcome to MV Tutors. My name is Firagahle Manana and we are doing the prelim exam for Gauteng, and we are now on paper number 2. Okay, let's get right into it with question 1. So let's read the question. It says a survey, if we look up here, a survey was conducted among a group of learners to compare the time spent on Instagram to the time spent on TikTok. The results are shown in the table below. Time spent on Instagram, there it is. Time spent on TikTok, there it is. Okay, so what's the question? Calculate the correlation coefficient of the data. Well, in order to do this one, correlation coefficient, remember, is the R value. And in order to do it, we basically just need the calculator and put this data on it. Okay, let's do that right now. There is our calculator. So we go mode, we go stat, which is number 3, and then it's 2 variables here. So we press 2. X will represent Instagram. So we'll put the data for Instagram, which is 30 equals 45 equals 58 equals 63 equals 75 equals, and then 90. So equals, that's it. Go to the side and go upstairs. Now Y will represent TikTok, so it starts at 40 equals 55 equals 70 equals 60 equals and 90 equals, and then 100 equals, let's see, 6 for 6. Cool. From there on, we'll press AC. The data is already on the calculator. So what we're going to do is going to look for stat again. It's number 1, so we go shift stat, and what we are looking for is with reference to the regression line. So reg, which is number 5, we press 5, and then the correlation coefficient is R, right? So we'll press 3, and then our answer is 0.96. We'll write it in 2 decimal. Cool. So our answer here, let's just check the question number. Let's go back. It's 1.1. So our answer for 1.1 is R is equals to 0.96. Okay. Now it says comment on the strength of the correlation between the time spent on Instagram and the time spent on TikTok. Well, we can clearly see that the relationship is actually very strong. 0.96 is close to 1. So we can say very, very strong. Very strong correlation. Okay, and then 1.3, determine the equation of the least square regression line for the data. Okay, to get the least square regression line, I like to go to the calculator first. Okay, and remember when we were looking at the modes here, like mode stat 3, and then it actually gave us the equation, okay, that we chose for 2 variables. And just to remind you what it looked like, 1.3, it looked like this. It said y is equals to a, right, plus bx. This was the way it was set up. It's a regression line. Okay, so now let's go to our calculator. Let's look for our value of a. So we go shift 1, regression information. Again, we're looking for the value of a, which is number 1. Press 1. Don't forget to press equals. Okay, so now we have that y is equals to the value of A is actually 8.12 if I'm just taking 2 decimal places, plus let's go look for the value of B. We'll go clear and then we'll go shift 1, regression line number 5, value of B is number 2, and then press equals. So the value of B is given as 1.01x, and that is our final answer. Right, so that was 1.3. Let's go look at 1.4. 1.4 says predict the time that will be spent on TikTok if a learner spent 115 minutes on Instagram. Okay, so for this one, there's a few things that we must know. Let's go 1.4. What is represented by X and what is represented by Y? Okay, now when we were putting the data on the calculator, X, you remember, was represented Instagram, the data for Instagram, and then Y represented for TikTok, right? TikTok, when we put the information in the calculator. So the question says predict the time that it will be spent on TikTok if a learner spent 115 minutes on Instagram. So X, then for the value of X, that's where we have 115, and Y is the one that we're looking for. So it's not so bad because we have our equation there given by Y is equals to 8.12 plus 1.01. Now where there's an X, we will substitute 115. So 115 there, and then let us see what answer we get if we put this in a calculator. You can now go back to your normal mode. So we'll just go 8.12 plus 1.01 times 115, just like that, and then we get 124.27, 124.27. Okay, what did it say? Predict the time spent, and then this is minutes because we were given in minutes. Okay, that's our final answer for 1.4. Let's now go look at 1.5. Let's come down here. Now, it was noticed that for learners data was not recorded. Okay, for learners is missing from the data above. The mean time of the TikTok users and Instagram users was 73.4 minutes. This is the mean time, meaning the average time, and each. Okay, so this is very important. Each. The researcher commented that the total amount of time spent on the two social media platforms was more than a full day. Okay, do you agree with the researcher? Motivate your answer by using necessary calculation. Okay, that's not so bad. So what we're gonna do actually for this question, let me just pick a black pen. It's 1.5. What I'm gonna do is that, okay, they told us a mean is actually 73.4, but how do we calculate a mean? Okay, the mean is given by the total, okay, divided total data divided by the average. Divided by the number of data sets. Okay, So I'm just gonna say total. I will just write it as total. This is since we're talking about minutes, it's gonna be total minutes. Okay, and that's gonna be divided. Now it was noticed that 4, right? That 4 learner data set was not included. Okay, the mean time of the TikTok users and Instagram users was that. So how many data sets? We're just gonna go back up here and we will count them. So it's 1, 2, 3, 4, 5, 6. Okay, plus the 4 that are missing. 6 plus 4 is 10, which means our total number of data sets or of people is 10, because we're including the 4 that was missing. Now if you read the English, it says the mean time, the mean time, so it was equals to 73.4. So to calculate the total minutes, then total minutes, okay, we're gonna say we'll use this. It's gonna be 73.4 times 10. This is times 10. This is just gonna give us 734 minutes for each. Okay, so for each means because they said each there, it means for TikTok and Instagram. So for Instagram and for TikTok. So Instagram is taking 734 minutes. Also TikTok is taking 734. The total time of this, let's just add them up, is 734 plus 734. It gives us 1468 minutes. This is the total time now. Now it says here, the researcher commented that the amount of time spent on the two social media was more than a day, a full day. How many minutes does a full day have? Well, we don't know, or do you? But you do certainly know how many hours are in a day, right? Okay, so let me just say day has how many minutes? It has 24 hours. To convert 24 hours into minutes, I multiply this by 60, because there are 60 minutes in an hour. Okay, so let's go 24 times 60. This is just to convert. Now we know a day has 1440 minutes. Now the researcher concluded that it's more than a full days, and you can actually see that 1468 is actually more than 1440. Okay, you can see 68 is bigger than 40, right? So which means now we can, it says, do you agree with the researcher? The researcher's conclusion is very correct. So yes, comma, I agree. Almost said we, but I agree. Okay, I agree because the calculation reveals that it's more than a full day here. The calculation reveals that it was more than a full day. It was more because a full day has 144 minutes. Okay, then a full day. Well, that's it for question 1. I hope you understood, and we do appreciate you. Please like and subscribe on this channel. It helps us very much with the algorithm, and it helps to get this information to the other students. Well, other than that, I appreciate you. See you on question 2. Okay, let's read question number 2 now. The amount of money in rands that a group of learners spent on a theme park on a specific day was recorded. The data is represented in the cumulative frequency graph or GIF below. So here we go. The thing to remember with an OGIF is that these values are accumulated. Okay, it's always a tricky part. Now it says the data from the cumulative frequency or GIF is represented in the incomplete frequency table below. There we go, as you can see it. And then it says how many learners visited the theme park on that specific day. Oh, nice. That one we can just look at the graph. If you look here, it says cumulative frequency, which is going to look at that last data there. It says 25. So what does that mean? It means our first answer is 25. This was question 2.1. Is it just 2.1 or it's 1.1? 2.11. So that's 25. How many learners? So it's 25 learners. Okay. All right, now let's go ahead and look at the next question. It says determine the values of A and B in the frequency table. The value of A is the very first one, and as you can see, 0 is between 10 and 50. Between 10 and 50, the total there. These are number of learners now, so we need to go to read that cumulative frequency. Remember, this y-axis represents the number of learners. Okay, so that's that value there, which is actually just 3. So this is now 2.1.2. So it's A, the value of A is equals to 3. B, where's B? So here we told it 6. How do they get 6 for this next level? They say 9 minus 3 gets 6, because remember these are cumulative, right? Now B is this one's between 100, there's 100 and 150. Cool, we've got 15. So we say 15 minus 9. What's 15 minus 9? If you said it's 6, then you are correct. So the value of B is simply 6. Cool. Let's look at the next question. It says use the OGIF to determine the percentage of learners that spent more than 175. Okay, so 175, if we look at the money spent in rands, remember these are the amounts. 175 is right over there, right? So we go up there, right? And then we want the value that it is associated with, which is over there. It's that's 15, 16, 18, 19. It's right over there. Cool. So it's 19. All right. So 175 is 19. That's the value there. Let's use a different color pen. Let's go purple. So this is now 2.1.3. It said more than, so the other value more than means 175 and this last one's there. I don't know why I drew it shaky. My hands were shaking. It should be straight, but anyhow, there we go. It should be like that. So this is where it's more than, right? And the question, it says use the OR graph to determine the percentage. So to solve a percentage, first of all, I'm gonna say the total, which is 25, right? If we look up there, which is 25, I'm going to say 25 minus, because we just want this area here, right, between these two blocks. So it's 25 minus 19, and we get that it's 6, right? So 6 learners have a percentage that is higher than spending 175 rand, and it's 6 out of a total of 25. Now, because we want a percentage, we'll multiply with 100. Okay, let's get our calculator. All right, so it's 6 divided by 25 times 100. Oh, that's 1,000. 100, and we get 24%. Okay, so if I'm to complete this, I will say 24%, okay, of learners spent more than 175 rands. Cool. Okay, let's check the next question. Right. Ooh, so many words. That's 2.2. It is further given that there are 2 rides at the theme park. One is called the Intimidator, the other one Terra Trails. The mean amount of money spent on these rides was analyzed and it is given below. Okay, so the mean for the Intimidator is 1320. For the Terra Trails, it's 1270. Cool. Now the 2 standard deviation intervals about the mean for the Intimidator was calculated as that. So this one is strictly for the Intimidator. Okay, that information, and that is the standard deviations for the 2 standard deviation intervals about the mean of the Intimidator is this. So the 4.8 is the lower one, 9.2 is the higher one. So it says if the standard deviation of the Terra Trails is double, okay, it's double the standard deviation of the Intimidator. Calculate the interval for 1 standard deviation about the mean of the, okay, so let's put these into perspective. Let's choose a color. Let's go green. Okay, so this is now 2.2, right? Okay, yeah, let's put this information into perspective. So they are saying the mean, remember 2 standard deviations, these are the mean amounts. So I know that the mean is given by that symbol that symbolizes the mean, minus the standard deviation. Standard deviation is given by that, okay, is equals to the lower one. When we subtract standard deviation is the lower interval, 4.8. This is for the Intimidator, which I'll call it I. Okay, now let's talk about the Terra Trails, which I'll call it T. Now, for the Terra Trails, we are told that the standard deviation of the Terra Trails is double the standard deviation of the Intimidator. So the mean minus double standard deviation. So it's 2 times standard deviation. This is for territorials. It still equals to 4.8. Okay, but we know that the mean for the intimidator, if I'm just to substitute numbers, is 13 rand 20 cents minus 2 is equals to 4.8. This is we are now going to calculate the standard deviation of territorials. So all that's left now is just to do gymnastics. Bring this number this side so that it's 1320 minus 4.8, and then I take the standard deviation that side, it becomes positive. Okay, and then I get rid of the 2 by dividing both sides by 2, like that. And then I'll put that in a calculator, right? I'm gonna go 13.20 minus 4.8 upstairs, and then I go downstairs, divided by 2. What's that equals to? Oh, let's change it to decimal. Therefore, the one standard deviation for territorials is 4.2. Okay, we will end it just there. I know the English is always the one that's a lot in these types of questions. The mathematics of it is fairly easy. It's just the English that they try to confuse us with. So we need to read the English very properly so that we know what we are calculating for. Okay, well, that's that. If you've learned something today, please like and subscribe on our channel. You can also comment if you like. All of this helps out to spread this video around on YouTube. Okay, well, that's it. See you on the next question.
Hello everyone. I'll be looking at question 3 with you guys. So let's go ahead and tackle it. Guys, please make sure that you score as many marks in this section, because a lot of you complain about trig and Euclidean. So yeah, let's just make sure we bag as many marks as we can with the other questions, so that if the going gets tough in the later sections, we can be reassured that we've done our best in sections like these. Okay, so it says in the diagram below, ABC are vertices of triangle ABC. E is the y-intercept of AB. F is the midpoint of BC. The angles of inclination of AB and AC are 135 degrees and alpha respectively. Okay, so 3.1. Calculate the gradient of AB. Okay, so there we see there is AB, and we've already been given the angle of inclination. So we can use our formula where it says tan 135 is equal to the gradient AB. And we can see this is 2 marks, right? So it's just a straightforward question. We're just going to check what tan 135 is. And I had already done it before to check. So it's -1. Okay, so the gradient of AB is -1, and we can see, yes, we do have a decrease from A to B, so we are expecting to have -1. Now 3.2, show that the value of P is 5. So P is the x-coordinate of B. So I will then go back, remember, gradient of AB, and then the y-coordinate of B minus the y-coordinate of A over the x-coordinate of B minus the x-coordinate of A. So let us now substitute what we know. The y-coordinate of B is -2. That of A is 4. The x-coordinate of B is P, our unknown, and that of A is -1. And we know that our gradient is -1. Okay, so if we just simplify, we have -1 is equal to -6 all over P plus 1. So if we take p plus 1 to the other side, okay, I'm just going to leave it in its brackets. P plus 1 will be equal to negative 6 divided by negative 1, which is just 6. So therefore we have p is equal to 5. Guys, please don't mind the background noise. I'm actually at a hospital and I should be just chilling, but I thought, oh my word, let us finish this paper because our students are writing finals soon. Okay, so yes, now we get to 3.3. It says calculate the coordinates of C. So this is where C is. Okay, so if I have a look at AC, I don't have much information. I only have the coordinates of A. I don't even know what alpha is, so I can't really use that much information on that end. But if I have a look at BC, I know that F is the midpoint of BC. Okay, so if I were to have with my midpoint formula for BC, all right, F would be, the coordinates there, 0 and negative 4. Okay, so I can use that to get the coordinates of C. And what would I do then? So I would say the x-coordinate of B plus the x-coordinate of C divided by 2 would be equal to 0. Okay, and the y-coordinate of B plus the y-coordinate of C over 2 would be equal to negative 4. So x-coordinate of B is P, which we worked out, and it is 5. So 5 plus the x-coordinate of C all over 2 is 0. So at least our only unknown is x. All right. So if we take 2 to the other side, it's going to be 0. And then 0 minus 5. So x-coordinate has to be a negative because C is in the third quadrant. So we have there x is equal to negative 5. Now let's go and see what the y value is. So our y value for B, we worked it out. No. We have it. It's negative 2. So we have negative 2 plus the y value of C. All over 2 is negative 4. We take 2 to the other side. We have negative 8. So negative 8 plus 2 will give us negative 6. Okay. So there we have it. Coordinates of C. We have minus 5, minus 6. It makes sense. It's in the third quadrant. Both y and x are negative. Okay. Wow, and it's only 2 marks. Is it just 2 marks? Yes, it is. It is. They're expecting you guys to know this and do it quick. Okay. Now 3.4. Determine the equation of AC in the form y is equal to mx plus c. So in this case, really, we have the coordinates of C, right? We have it as negative 5 and negative 6. For us to get the equation, we need a point. You can either use A or C. And we also need a gradient. So how do we... Yeah, let's just go ahead and get the gradient first. Okay. We're going to probably get it the long way. How many marks is this? It's 4 marks. Okay. So let's get the gradient first. We can use our tan alpha formula. It's equal to the gradient of AC. Yeah, but we don't really have alpha. So let me not even go there. Let's just get the gradient. Okay, we have both A and C. So gradient of AC is equal to the y-coordinate of C minus the y-coordinate of A all over the x-coordinate of C minus the x-coordinate of A. Now the y-coordinate of C, we worked it out. So guys, if you made a mistake somewhere, unfortunately, you're going to carry forward with that error. But at least they will give you some marks. Okay, just to say that at least you know what's going on. It's just your answer will not be correct. Okay, so there we go. Now negative 6 minus 4, that's just going to be negative 10. And minus 5 plus 1, it's going to be minus 4. So our gradient here, if we simplified, it will be 5 over 2. Okay, so we have a gradient, we have a point. Can we get the equation? Most definitely. So we have y is equal to mx plus c. Let's get c. I will take the coordinates for A. So in the place of y, I'll put 4. In the place of m, 5/2. In the place of x, -1. And let's find out what c is. So we have 4 is equal to -5/2 plus c. And let's just check quickly on the calculator. I'm not even going to try to do it in my head. So 4 plus 5/2. Actually, it's like 4 plus 2.5. That's going to be 6.5. Or let's just go with the fraction, which is 13/2. Okay. So then we can write our equation. So y is equal to negative. No, we don't have a negative. Y is equal to 5/2x plus 13/2. Does this answer make sense? This is for equation AC. Now, AC, the gradient has to be positive because we're going all the way up. And our y-intercept looks like it's going to be somewhere over there. So yes, it makes sense that we have 13/2. And yeah, I'm good with this equation. I'm confident in it. So we can move on to question 3.5. Calculate the size of A. Okay, A where we have CAB. Okay, just take out everything. Just write that again. What did we say? -5 -6. So we are looking for A, this size over there. Okay, so what I'm thinking is, I'm going to focus on this triangle. If I get what alpha is, I can already get this value over there, okay, by using angles in a straight line. So let me just say, let me see what alphabets we haven't used. Let me just say this is M and N. Okay, so if I were to get the angle N, angles in a straight line, I would just say 180 minus 135. All right, and what does that give us? That is 45. Okay, so I know that N is 45. And then if I were to get M, I would say tan alpha is equal to the gradient of AC. And the gradient of AC is something that I've already worked out before, and that's 5/2. Okay, so alpha will be the inverse of tan, and we have 5/2. Okay, so then alpha will ultimately, so let us say shift tan, and 5/2 is just 2.5. So I get, please make sure that your calculator is in degrees and not radians, because you might get wrong answers. So 68,2 degrees. Okay, so I have alpha, I have N, so I can get A, right? So A plus my alpha, yeah, please don't mind the noise. Let me just say A, angle A in CAB is actually equal to 180 minus 68,2 minus 45 degrees. I think it's better if I put it that way. Okay, and then what answer do I get? Let's just take out the calculator. So this is angles in a triangle are equal to 180 degrees. So I'm just going to say 180 divided by the answer. Sorry, minus the answer, minus 45 degrees. And I get an answer of 66,8 degrees. All right. Alrighty, now coming to question 3.6. So it says calculate the area of triangle BEF. Okay, where is triangle BEF? There's E, Okay, and there's F. There's our triangle. What do we know at this point in time? We know the coordinate of F and B. We don't know E, we just know that it's the y-intercept. We don't have any angles as well. So with a triangle like this, because it's not a right angle triangle, I'm tempted to use the area rule, where I have one side, which I can get, which is FB, and it would be in my best interest to get E, the coordinates of E, right? So that I can get another length. Okay, maybe this length or that length. But let's see which angle would be easiest to get. Okay, so if I can get, actually the easiest angle to get, because here I have a 90-degree, a right angle triangle. I know this is 45. E would also have to be 45. So if I know that E is 45 degrees because of sum of angles equal to 180, then I can get the side of EB. I need to get what EB is, and I also need to get what EF. Yeah, if I can get this side and that side EB. So what is the formula of the area rule? Basically, I would say, so the area of triangle BEF, just shift this side. Okay, area of triangle BEF will be equal to a half, so the one side, which is EB, times the other side, which is EF, and multiplied by sine E. Okay, so I have E, it's 45 degrees, but I need to get the coordinate of E so that I can get the length of EB as well as the length of EF. By the way, if you have a simpler way of doing this, because this is only 3 marks, please do comment below for others to adopt. I'm just going to go about it the long way. Okay, so if I have E there, E is the y-intercept of AB. Okay, so let's just get the equation for AB, because I have the gradient. I think it's something we determined earlier on. It was -1. First question, I believe. And we have a point. I can use point A. So y is equal to mx plus c. And we're trying to basically look for c, okay, which is E in this case. The y-coordinate of A is 4. The gradient is -1. The x-coordinate is -1. And we're looking for c. So c is 4. -1 and -1 is +1. We take it to the other side, -1. So c, which is actually E, will be, let me just remove that. Let's just say E would be 0 and 3. Okay, now we have the coordinate of E. We can then get the distance EF, or the length of EF. Okay, so therefore the length of EF, it's going to be straightforward. I hope that you see it. But basically, if F is -4 and we have 3 here, the distance really between E and F would be 7. Okay, because I have -4 minus -3, or just, yeah, or I would say 3 minus -4. Okay, from top to bottom. Okay, so the distance there is 7 units. That's EF. So we have EF, we have sine E. Now we're left with EB. EB, we're just going to use our distance formula. Okay, so x-coordinate of B, which is P, which we found to be 5, be 5 minus the x-coordinate of E, which is 0, and we square it. And then we add the y-coordinate of B, which is -2, minus the y-coordinate of e, which is 3. And we square it, and everything will be under a square root. So we have 5 squared, which is 25. And again, negative 5 squared, which is 25. So basically, EB will be root 50. And I'm just going to leave it as root 50. I'm not going to simplify it at this point in time, because I just want to get to the area. My goodness, we have worked so much. So triangle BEF is equal to a half 7 multiplied by root 50 multiplied by sine 45. Okay, I'm going to put all of this into the calculator and we're going to multiply. So a half times 7 times root 50 multiplied by sine 45, which is a special angle, and we get 17 and a half. I'm going to write it in decimal form. 17 and a half, and this is area, so please don't forget squared units, a unit squared. Okay, and that is it with question 3.6. Alright, so we've arrived at the last question, 3.7. Thank you for bearing with me. Another point K, which has coordinates TT, where t is less than 0. So if t is less than 0, we are basically looking at the third quadrant where both x and y are negative, right? So it is plotted such that AK, so let's say K is somewhere here, and we have A over there. I don't know, is it a point on AC or it's just a random point? I don't know. All I know is K is in the third quadrant. So if you were to plot AK, basically the length of AK would be 5 root 5. Now we need to calculate the coordinates of K. So they've given us the distance, right? So using our distance formula to get AK, I'm so tempted to say AKA, but yes, to get AK, basically I would have the x coordinate of K minus the x coordinate of A, and I would square that. Then I'll get the y-coordinate of K minus the y-coordinate of A. Square that, and everything will be under a square root. So I've been given the distance, which is 5 root 5. Do I have the coordinate of K for x? No, that's what I'm looking for. For A, yes, I do have the x coordinate. It is negative 1, so that's just going to be plus 1. And actually, let me just write this as t, okay? So that it's clear. And then the y-coordinate of K, which is also t, the y-coordinate of A is negative 4. Okay, so I'm going to take the square root to the other side. It's going to make my life a bit easier instead of having to take it with me all the time. So I have t plus 1 squared plus t minus 4 squared. I think it would be in our best interest to just get rid of the brackets and simplify. So t plus 1 squared will basically be t squared plus 2t plus 1, and then I have plus t squared minus 8t plus 16. Alright, and let me just simplify that. So I have 2t squared, and then I have 2t minus 8, so it's negative 6t, and then I have 1 plus 16, which is 17, and I'm going to subtract the root, the 5 root 5, and then square it. Okay, so it's basically 125, so I'm subtracting 125. Alright, and let me just simplify it again. If I say 17 minus 125, I get a negative 108. So 2t squared minus 6t minus 108. Let me divide all of that by 2. So I have t squared minus 3t, and negative 108 divided by 2 is negative 54. All right, and then I can use my quadratic formula. Again, I like looking at the marks. Okay, 5 marks. So we are going to work. So you can either use your quadratic formula, or if you want to have a look at the factors of 54 that will give you 3, you can do that as well. I think I'm going to go that route because I feel like the quadratic formula takes long, and it probably doesn't, but hey. So 54 divided by 3, oh gosh, 54 divided by 3, that's 18. 54 is 4 divisible, I don't think so. 5, no, 6. So we have 6 and 9. So yes, definitely going to use 6 and 9 in order to get negative 3. So I'm going to say negative 9 plus 6. So therefore t is equal to negative 6, or t is equal to 9. But we cannot have 9 because we know that t has to be a negative value, right? Because t has to be less than 0. So therefore it cannot be 9. Therefore k would be negative 6 and negative 6. Okay, and that is question 3. All right. Yeah, I hope you learned a thing or two. If you have anything to say, to comment, to add, please do so in the comment section, and we appreciate you. Thank you. See you in question 4. Question 4. In the diagram below, the circle centered at M passes through A and C. BA and BC are tangents to the circle at A and C respectively. BC is parallel to the y-axis. Okay, so just by looking at BC and BA, it's safe to conclude that actually they have the same length. Alright, so if we have two tangent lines meeting at a point, then those tangent lines, or the length from the tangent to the circle up until point B, so from A to B, those lines are equal in length, but that's just extra information. All right, and yeah, I think let's just answer the questions that follow. So 4.1, determine the equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared. So we already have a center, and as such, in the place of A, we will then put negative 2, and in the place of B, we will put 3. But we still need to work out what the radius is. So let me just simplify this. So I have x plus 2 squared plus y minus 3 squared is equal to r squared. If you want to get the coordinates of r, I would suggest we get the distance of MA. Alright, and the x coordinate of A is 1 minus that of M, negative 2, and all of that is squared. The y coordinate of A is negative 1. Y coordinate of M is 3. So we square that and we root everything. So 1 plus 2, that will be 3. 3 squared is 9. And then we have negative 1, negative 3, which is negative 4. Negative 4 squared is 16. And 9 plus 16 is 25. Root 25 is 5. So at least we know what MA is, and MA really is our radius. Okay, so our radius is 5. So finally, for 3 marks, the equation of the circle is x plus 2 squared plus y minus 3 squared is equal to 25. Or if you wanted to put 5 squared, I think that would still be fine. Alright, now 4.2. Write down the coordinates of C. Okay, so we know that line CB is parallel to the y-axis that was given. And also, from the center to the circumference where we have a tangent line. Actually, we know that tangent BC is perpendicular to the line or the radius MC in this case. So as such, we can then say the y coordinate of C would be 3. Okay, now what would be, sorry, I just said the y coordinate and I'm writing it in the place of x. Okay, now how do we get the x coordinate? So we know that our radius is 5. Okay, we worked it out in the previous question, and we know that this point here is -2. So if our radius is 5, if I go -2 and then 5 units from -2 to the left, okay, I will be at -7 once I get to C. Okay, so therefore 4.2, the coordinates of C would be -7 as well as 3. Okay, we got that -7 by saying -2 minus 5. Alright, and then 4.3, determine the equation of the tangent AB. Okay, so we're looking for AB in the form y is equal to mx plus c. So in order for you to get an equation of a line, you need a point first of all. So we can use point A, which is 1 and -1. And then we need a gradient. Okay, so we don't have a gradient at the moment, but we know that our radius is always perpendicular to our tangent line. So let's get the gradient of our radius. Alright, so we're going to get the y coordinate of A minus that of M, not B. Alright, and then the x coordinate of A minus the x coordinate of M. So the y coordinate of A is -1, and that of M is 3. The x coordinate is 1, and that of M is -2, so that will be +2. So now we get -4/3. So that is the tangent of the radius. What am I saying? That's the gradient of the radius. Now what would be the gradient of our tangent? Well, basically, if you take the gradient of your radius multiplied by the gradient of your tangent, and you get -1. Okay, so if we're working back, our gradient of the tangent will actually give you 3/4. Because if you say 3/4 multiplied by -4/3, you're going to get -1. Okay, so now we have our point and we have our tangent. Therefore, we can substitute in this equation to get the value of C. So in the place of y, we're going to put -1. In the place of our gradient, we have 3/4. In the place of x, we're going to put 1. And we can work out what C is. Okay, so C is -1 minus 3/4. We can actually turn this 1 to 4/4. Okay, so now we have -4 minus 3, that is basically -7. And so yeah, so basically now we can then say the equation of AB, tangent AB, is equal to 3/4 x minus 7/4. All right, and now 4.4, it says determine the length of BC. Okay, so we have the equation of AB. If we can get the length of AB, we can get the length of BC, but maybe that's going about it the long way. What do we have here? So in terms of B, what we do know is our x value is -7, but we don't know what the y value is. And we also know that B is therefore for line AB. So our equation for line AB, which we just worked out, is equal to 3/4 x minus 7/4. And so if we were to substitute point B in order for us to get y, Okay, so y will be our only unknown. If we substitute minus 7 there, what are we going to get? So we have negative 21 over 4 minus 7 over 4, and that's basically negative 28 over 4, which is negative 7. 28 divided by 4 is 7. So yes, so B therefore has the coordinates of minus 7, minus 7. All right, how does that help us? It helps us because we can then get the length of BC. It's actually easier that way, because we know that C, let's just remind ourselves, C is negative 7 and 3, right? That's what we determined. Yes, negative 7 and 3. And we know that BC is actually parallel to the y-axis. So in order for us to get the length of BC, we're just going to get the difference between, or get the distance rather between CB or BC. And up until we get to the x-axis, we have 3 for this portion. And up until we get to point B there, we have 7, right? So basically, the length of BC is 10. Or you could have said 3 minus 7, which is 10 units. Okay, so that's the length of BC. Okay, and then 4.5. It says determine the equation of the circle centered at A. Okay, so I have done a whole lot here. Let me just erase everything and start again. Okay. Alright, so let's just fill in what we know. Alright, so we have determine the equation of the circle centered at A. So the center is there, and it has both the x and y axis as the tangents. So we're looking at a circle that's probably something like, not like a circle there. So maybe, okay, I'm not gonna draw a perfect circle, but you get the picture, right? And yeah, so basically we have a radius of 1. I hope you see that. Yeah, that would just be 1. Yeah, so our radius is 1. And then the center. Oh yeah, that's all you need. You need a radius and you also need a center in order for you to get the equation of a circle. So that's it. So we can then say x minus 1 squared plus y plus 1 squared is equal to 1. And that is the equation of that circle centered at A. 4.6. If another circle with center N and a radius of 4 intersects the circle centered at M at 2 distinct points, determine all the possible values of P. Alright, so as a visual learner, I'm just going to try to see how is this looking. So we know that the y value is 3. And with the current circle that we have, the y value is also 3. So I'm just going to put a line here just to show that for both circles, or all possible circles, the y value has to be 3. So we have two options. Either you have the one circle on the left, okay, so it has a bigger radius, or we have another circle on the right of this existing circle. Okay, and yeah, now we need to get all possible values of P. Okay, so I have done a video on one of our playlists where we do cover analytical geometry, especially circles, and I do get into details regarding circles that intersect, circles that are concentric, or that just touch one another, or different scenarios. Go have a look at that. I hope I'll just put in the link into the description below, and you can also have a look just to see other scenarios that they might ask. But let's just say we have circles that are intersecting. Okay, regardless of where they are intersecting. First of all, you would have the first radius, okay, and that would be the second radius. And then you have the distance between the radii. Okay, so basically if you want to test for circles that intersect at 2 points, you would say that that distance d is actually in between the difference of the circles as well as the sum of the circles. And that's exactly what we're going to use. But this time, we're going to have two scenarios because, like I said, you could have the circle being on the left side of the original circle or on the right side of the original circle. Okay, so 4.6, I will then say we're going to have the radius of m minus the radius of n being in between the distance d. So let's say this is the distance d for the first scenario. Okay, this distance d, as you can see, would be, remember for the circle n we have p. Okay, so this you could say p minus 2, okay, which is simply p plus 2. So you have p plus 2, and then we have our radius at m plus our radius at n. That's if when we have the circle to the left. Now what happens if we have the circle to the right? Same scenario, the radius of m minus the radius of n in between d. And what is d this time? So here we have our minus 2 and here we have p. Alright, so I'm just going to say minus 2 minus p, and we have the radius of m plus the radius of n. So let's just fill in all the missing values and see what possible values of p we could have. So the radius of m, you know, we've calculated it before, it is 5. And that of n, they gave it to us, it's 4. Okay, we have p plus 2. And again, we have 5 plus 4. Alright, so that's basically just 1, p plus 2, and that's 9. Same thing on the right hand side, the circle on the right. We're also going to have 1 if we take the 5 minus 4. But now we have minus 2 minus p, and that's 9. Alright, so if we distribute the 2 so that we only have p, 1 minus 2, that will be minus 1. And 9 minus 2, that will be 7. So that's the range of the first possible values looking at the left, the circle being placed on the left hand side of the original. Now on the other side, if I distribute the negative 2, I will have 3 this side, and I will have 11 that side. But because I have a negative p, I need to have a positive p. Okay, so basically what does that negative do? It swaps things around. Your things will start facing that way. Okay, but I don't like it when the inequalities are like this. So I'd rather just say negative 11, p, and then we have negative 3. You want to start with the smallest and end up there at the biggest. Okay, so those are all the possible values of p. If the circles were to intersect at 2 places. Alright, but again, please have a look at that video in the playlist, the maths playlist, where you can see different scenarios, because in the exam they could ask something different. Okay, but that's it for question 4. 5. In the diagram below, P is the point 12, 5. Okay, of our x and y coordinate. And T is AB. Okay, so there it is. OT is perpendicular to OP. We can see that with the 90 degree there. And PS is perpendicular to the x-axis. And POS, so angle O, is theta. Now, without using a calculator, determine the value of tan theta. Alright, so what would tan theta be? Remember, tan is opposite over hypotenuse. So we already know that PS, being our y value, is 5, and OS, being our x value, that is 12. Alright, so tan would be 5 over 12, which is y over x. And we can leave it there because we're not using the calculator. And it's only 1 mark. Now it says sine theta. Alright, so in order for us to get sine theta, we're going to need the hypotenuse. So our r value there, what would that be? Okay, because we know with sine theta, we have opposite over hypotenuse. Okay, now with the hypotenuse, we say r squared is equal to x squared, which is 12 squared, plus 5 squared. Alright, and mind you, we're not supposed to be using calculators, so I hope this is doable. So we have 144 plus 25, which is 169. I hope you can see that root 169 is actually 13. So now we know what our r value is, which is 13. Okay, and that is 2 marks. Now 5.1.3. Now we need to determine the value of A. So A is our x value over here. We are expecting a negative value for A. Okay, that's B. If TO is 19,5 units, so we have 19,5 units over there. Okay, I feel like erasing things. It's getting a little bit crowded over here. All right. Let's see. Let's look at this with fresh eyes. So if we're looking for A, our x value, so this entire thing here is 90 degrees plus theta. All right. If I were to use this triangle, all right, which is, this would be A, that would be 19,5. And what would this angle be? Okay, if I were to reduce it. So basically what I'm coming to here, I would have cos something, cos of that dot, would be equal to our adjacent, which is A, over 19,5. All right, but now let's have a look. What is this dot representing? Basically, we're in the second quadrant where we know that we have 180 minus x, for example, okay? And x would be what we reduce it to. So then in this case, we have cos 180 minus the 90 plus theta. And that's equal to A over 19.5. Now, according to the reduction formulae, I would have cos 90 plus theta is equal to A over 19.5. 90 plus theta is in the second quadrant. Cos is negative in the second quadrant, okay? And the cos 90 changes to a sine theta. So we have a negative sine theta is equal to a over 19 comma 5. We've already we've already determined what sine theta is, which is 5 over 13, but because of that negative, we're going to have negative 5 over 13 is equal to a over 19.5. Now they said we shouldn't use a calculator, but I don't know. Can we continue without using a calculator though? So in this case, our a will be equal to negative 5 over 13 multiplied by 19, comma 5. We have to use the calculator. I don't know how else we're supposed to get it. But we know that a is supposed to be negative regardless. So we have negative 5 over 13 multiplied by 19, comma 5. If we were not to use the calculator, it would take us forever. Okay, so basically a then is equal to negative 7.5. So yes, it has to be negative because we're on the negative x-axis side. So that's 5.1.3. Now we can go over to 5.2. Again, we're supposed to determine the value of the following without using the calculator. So here we'll be using our reduction formulae again. So we have 360 minus 2x, and then we have sine negative x all over sine 90 plus x. If you tend to be confused sometimes, please draw the Cartesian plane yourself. See where what is positive, what is negative. I'm just going to draw it at the bottom here, hoping that I won't run out of space. But this basically would be theta, or you would have 360 plus theta. Okay, so basically here you have 0, 90, 180, 270, 360. So here we have 360 minus theta, we have negative theta. There we have 180 minus theta, we have 90 plus theta. Here we also have 90 minus theta, but the main one in this quadrant is theta. Okay, then we have 180 plus theta. I think let's just leave it there. The main ones is what I'm going to just highlight over here. Okay, so now that we have that out of the way, we can then start to reduce. If I have sine 360 minus 2x, I'm in the fourth quadrant. I know that sine is negative there. All right, so I will have negative sine 2x. Then sine of a negative angle will be negative sine of that angle. The only exception is cos. Cos of a negative angle will be a positive cos, okay, of that angle. Now sine 90 plus x, I'm basically in quadrant number 2 where sine is positive, and I know that sine and 90 can change to cos x. All right, so that's that. And then when I come to this plus, another way of writing it really, so as not to confuse yourself, you can then say it is, you can leave the 2 out. You can say cos 180 plus x, and all of that is squared. Okay, that helps. And I say this because cos 180 plus x is in the third quadrant, which is negative. So basically, we have negative cos x, but everything is squared, so it will end up being a positive 2 cos squared x. Okay, but we'll see it next. So now when it comes to sine 2x, it is a double angle. At least with sine of a double angle only has one answer to it, unlike cos, so we can expand it. And I can take these two negatives, multiply them with each other, and I get a positive, so I don't have to keep writing negative all the time. Okay, so then I have 2 cos x sine x. I have sine x over here, and then I can divide it by cos x. And then here I have plus 2 cos squared x. Okay, so that has simplified my sum significantly. Now I can cancel out the causes, and I have 2 sine squared x plus 2 cos squared x, which is great. If I take out the 2, I'm left with sine squared x plus cos squared x. And I know that that's an identity that's equal to 1. So my final answer then is 2. So that was good. Now 5.3, given cos 42 degrees, okay, cos 42 degrees is equal to root k. Without using a calculator, determine the value of sine squared 69 degrees in terms of k. Okay, what would sine squared 69 degrees have in common with cos 42 degrees? Because in cases like these, I'd be tempted to start off with my triangle, put in my 42 degrees, and say that it is adjacent over hypotenuse, so that would be root k over 1. But how does that help me to get to 69? Because 42 plus 69 is not going to give me 90 degrees. Alright, how can I relate 42 and 69? If I get the co-ratio 42, it would be 48, meaning what would I add in order to get 69? In order to get 90. So that's 48, but that doesn't help me. If I were to then say, what should I add to 69 in order to get 90 degrees? That would be 21. Okay, now does 21 relate to 42, 48? It does relate to 42. Actually, 42 is 2 times 21. Alright, so now how do I go back and relate the 2 again? Okay, so I know I'm working with 42, I'm working with 21 degrees, and I'm working with 69. So coming back to what I have over here, if I were to say cos 2 times 21, that is cos 42, right? And that is equal to root k. Now, how do I then, if I have sine squared 69, let's actually do it this way. If I have sine 69 and all of that is squared, what is the co-ratio of sine 69? It would actually be cos 21. Okay, so I'm going to go to my double, double angles, okay, for cos, where I can have a cos squared. Alright, so for my double angles, I know that cos, let's say 2 theta would be equal to cos squared theta minus sine squared theta. And I also have 2 cos squared theta minus 1. Alright, the other one, it has to purely do with sine squared theta. So in this case then, I can either use this or that. But I don't think I want to explore the first option. I think I want to just play it safe with having just the cos squared. Okay, so let's write down the answer. Let's start officially. I will then say cos 2 times 21, which is cos 42. It's actually equal to 2 cos 21. I'm going to put it like this, squared minus 1. Okay. Then I know that cos 42, which is 2 times 21, is actually equal to root k. And I know that cos 21 is actually the same as sine 69. Okay, so root k is equal to 2 sine squared 69 minus 1. Can I then write sine squared 69 in terms of k? Yes, I can. I just need to jumble the numbers around. Alright, so I have 2 sine squared 69 degrees is equal to root k plus 1. And I'm just going to divide by 2 both sides. So basically I have sine squared 69 degrees is equal to root k plus 1, and all of them are divided by 2, and that would be my answer. Okay, this was very tricky. This was very tricky, but in questions like these, if the triangle doesn't work out, try to see, so all of this was just me thinking out loud. Try to see what relates between what they're asking you. Otherwise, yeah, answer this question last because it's going to take up a whole lot of your time. All right, and it's how many marks? It is 3 marks. Okay, 3 marks. You can always come back if there's time. Okay, and now let's go to 5.4. So it says, given the identity, prove the identity for 5.4.1. So we normally prove the left-hand side being equal to the right-hand side. Okay, the most complex side, rather work with that to get to the least complex. So I'm going to start with the left-hand side. And then we have sine 5x times cos 3x minus cos 5x. I hope bells are ringing in your mind as we write this. It's going ding, 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 ding. Not that it's red flags, but it's more of, I know what to do. Okay, so with what's happening in the numerator, it's sine, cos, sine. Okay, it's reminding me of the compound angle for sine. Okay, where we have sine 5x, and since there's a minus there, we're going to say minus 3x. All right, and in the denominator, we have tan 2x, and then we just subtract 1. So 5 minus 3, we're going to be left with sine 2x divided by tan 2x, which is really the same as dividing it by sine 2x over cos 2x. Okay, now if you are dividing a fraction, you can just multiply it. It becomes cos 2x over sine 2x. Now things are cancelling. Okay, so we have cos 2x, a double angle of cos, minus 1. Now, am I where I need to be? No, but I see there's a sine squared x. So I know that one of the identities for cos 2x is 1 minus 2 sine squared x. Okay, and we have minus 1. So the ones cancel, and we're left with sine 2, negative 2 sine squared x. And we have proved the identity. All right, now we get to 5.4.2. All right, so it says, determine the values of x for which the identity will be undefined in the interval from 0 to 60. Okay, so if it's going to be undefined, it means that tan 2x, first of all, has to be equal to 0 because anything divided by 0 is undefined. All right, and then what else that is pertaining to tan? Remember, tan is that function that has asymptotes at 90 degrees or intervals of 90 degrees. Okay, so we would say that tan 2x, okay, would be undefined if actually not the entire, so the denominator, yeah, actually I shouldn't have rubbed that out. So tan 2x is undefined if the angle, which is 2x, is equal to 90 degrees. Remember, like I said, when it comes to tan, We have 90, 270, negative 90. So at that point, at intervals of 90 degrees, you have your asymptotes. Okay, that should be a bit bigger. But you get the flow, right? Yeah, this would be 180, that's 270. Okay. So you always have your asymptote. So every 90, 270. What am I doing now? Yes, 270. Okay. So our period there being 180 degrees. But we know that at 90 degrees or 270 degrees, then tan, the function of tan is undefined. Okay, so the angle there, we need to make sure that the angle is equal to 90 degrees for it to be undefined. Okay, so you have two conditions. All right, and now if we were to get what the answer is for x, okay, basically x would be equal to 0 on one end, and if 2x is equal to 90, therefore x would be 45 degrees. Okay, so those are the values of x. And I mean, we could go on and on and on, but they gave us a domain where x has to be in between 0 and 60 degrees. If it was more than that, we would have probably said where 2x is equal to 270, and after every 180 degrees, we would have determined what the answers are. But for now, 0 degrees and 45 degrees are within the domain that was given, so we can stop there. And are we done with question 5? I don't know. Oh, no, we're not. So we're still going. Let's look at 5.5. All right, looks like it's short. So it says given the function, so we have f of x is equal to 2 cos x minus sine squared x. Now 5.5.1 says, show that f of x can be expressed as the following. All right, so let's write it down. The original as they gave us is 2 cos x minus sine squared x. Okay, I can't really do much with the 2 cos x, but I will change the sine squared x. It is an identity. Remember, sine squared x plus cos squared x is equal to 1. So I can then say 1 minus cos squared x would be equal to sine squared x. So then I have 2 cos x minus 1 plus cos squared x. And then I have cos squared x plus 2 cos x minus 1. And it's like I have a quadratic function. If this is a little bit too much for you to deal with, you can basically say let y is equal to cos x. Then you'll have y squared plus 2y minus 1, and hopefully it's easier to look at in this case. Okay, and basically, let's see, so you have y, okay, so in this case, maybe it'll be best to use the quadratic function. But wait, okay, never mind. I actually forgot what the answer should look like. So here I see that they actually wrote it in a form where you are completing the square. I hope that you see it. So if I were to complete the square, I hope you remember. So I would have y squared plus 2y plus 2 divided by 2 squared minus 2 divided by 2 squared and minus the 1. Alright, so I would group these together and those together. So then I would have y squared plus 2y plus 1, and then minus 1, that's the minus 2, so at least we're getting there. And then I have y plus 1 squared minus 2. Okay, and remember we said let y equal to cos x. So I have cos x plus 1 squared minus 2. Okay, and that is your f of x. So at least we have shown it and we have proved it. And that was only 2 marks. Alright, lastly, 5.5.2, hence or otherwise, find the maximum value of f. Alright, so the way we wrote it the format in which we wrote our answer. If you were to have, for example, maybe negative x plus 1 squared minus 2, it would be a sad face parabola, right? With a turning point of negative 1 and negative 2. And that would be your maximum value. But in this case, we don't have just a normal quadratic function. We have a trigonometric quadratic function, if I could say. Okay, so we're going to take it piece by piece. All right, what is the maximum value for a cos x function? If you were to draw a cos x function that has a domain of negative 360 to positive 360, it would look something like this. Okay, not exactly to scale. All right, and what would be the maximum value? You would either have a maximum value of 1 or a minimum value of negative 1. But the maximum value for a cos x function cos x would be 1. So if now I'm looking at the maximum value, f of x max, I already know that the cos x function, its maximum value is going to be 1. So I'm adding 1 to it, which is 1 plus 1 squared minus 2. And then I'll have 2 squared, which is 4 minus 2, and that is 2. Okay, so ultimately the maximum value for the function of f will be 2. And this is where we end question. Question 6. All right, so we are 50% done and 50% to go. So given the equation cos x minus 30 degrees plus 2 sine x is equal to 0, 6.1 says, show that the equation can be written as tan x is equal to negative root 3 over 5. All right, so there are various ways in which you can reduce this to a single trigonometric expression. But because we have to have tan at the end, I would suggest that you keep the sine and the cos and see how that works out, so that at the end we can just say sine divided by cos is equal to tan. And yeah, so firstly we have this compound angle, so let's just spread it out and see how we can simplify going forward. So we have cos x, it'll be the cos, sine, right? So cos x, cos 30 degrees, and this is a special angle, and we have a minus here, so we do the opposite, plus sine x and sine 30 degrees. Okay, and that's plus 2 sine x. I can't exactly expand that any further. So cos 30, if you're not sure what that is, it should be root 3 over 2, but if you're not sure, please do use your calculator and just check. Cos 30, so yes, that is root 3 over 2. And sine 30 degrees, that should be a half. And we are adding 2 sine x. Alright, so I'm going to add the half and the 2. So I get 2.5. I'll just put it as 5 over 2 sine x. And I will make it equal to negative root 3 over 2 cos x. Then I'm going to divide both sides by cos. So I will have sine x over cos x is equal to negative root 3 over 2. And I'm going to multiply it by this, 5 over 2, I'm going to multiply it by 2 over 5. Okay, and what I have then on the left hand side, sine over cos is equal to tan x. And if I cancel out the 2's, I have negative root 3 over 5. And we are done with 6.1. Now 6.2 says, determine the solutions of the equation cos x minus 30 degrees plus 2 sine x is equal to 0 in that interval where x is an element of negative 180 to positive 180. Alright, so I don't have to go back to the original sum. I can just use tan x being equal to negative root 3 over 5. Okay, and then I can get a reference angle. Alright, so our reference angle basically would be the arctan of root 3 over 5. And because of this negative, I know that I'll get the solution for quadrant 2, that's where tan is negative, as well as quadrant 4. Okay, so now let me get what the reference angle is. So I have the arctan, shift tan. Okay, we have root 3 over 5. And that gives us an angle of 19,11 degrees. Okay, so that is my reference angle. And then for quadrant 2, I know that is where we have 180 minus the reference angle. In this case, it's 19,11 degrees. And this is tan we're dealing with. So our period is 180 times k. And now let's go over to quadrant number 4. So that is x is equal to 360 minus our reference angle, which is 19,11 plus 180 times k. We always have to say that k is an element of integer. Okay, but only, I think for the first set, when you write out the equation, you don't need to repeat it all the time because, yeah, it's going to take up space and it's a little bit annoying. All right, so now what is our general solution? If we take 180 and we subtract the answer, we get 160,89. Okay, 160,89 degrees plus 180 times k. And now if we take 360 minus 19,11, we get an answer of 340,89 degrees plus 180 times k. Now they didn't ask us for the general solution. They said we must determine the solutions, all right? And in the interval of negative 180 to 180. So I will then take various values of k, all right? So if I had k is equal to negative 1, what would x be? Okay, so if I said 160,89 minus 180, I get negative 19,11 degrees, which is part of the interval given. So that's fine. And on the other end, if I take 340,89 minus 180, I get 160,89. Okay, so that's also within the range that was given, 160,89 degrees. Now if I take 0, k is 0, I will get 160,89. Okay, so I'm not going to try that. But if I try k is equal to 0 here, I'm going to get 340, which is outside of the range. So I'm not going to do that. And if I take k is equal to 1, I get very big values. So at the end of the day, the two solutions that I will go for is x is equal to negative 19,11 degrees as well as 160,89 degrees. And we are done with 6.2. Now let us get to 6.3. So it says in the diagram below, the graph of f of x, where we have negative 2 sine x, is drawn for the interval of negative 150 to 210. Okay, so we can see that the amplitude has been doubled and this graph has been inverted because of the negative. Okay, because we're normally used to our sine graph starting out like this, but now it's doing the opposite. And on top of that, it's actually doubled. The amplitude is doubled. All right, so I hope you see what's going on there. Okay, now it says write down the amplitude of f. Okay, so we can see the amplitude is 2. If you wanted to calculate it, you would say that the amplitude is actually your minimum or your maximum. Let's start with your maximum. So your maximum value minus your minimum, and you divide that by 2. So what is our maximum? Our maximum is 2. Our minimum is negative 2. So now 2 plus 2 is 4, divided by 2 is 2. So there we get the minimum. And I would suggest to use this equation, especially if the graph has been shifted up or down and you can't necessarily see that the amplitude is a certain value. All right, now 6.3.2, it says draw the graph of g of x. All right, where we have the cos graph shifted 30 degrees to the right. And for that interval of negative 150 to 210 on the grid provided, I'm going to just draw it over here, okay? The simplest way is to use your table method, okay? So go to your mode, table, and then put in the equations. In this case, we have cos x. Now I'm looking for my x. There it is. So x minus 30 degrees. Okay, and then we are starting it from negative 150, ending it at 210 degrees in steps of 30 degrees. And now we see, so for negative 150, I get negative 1. All right, negative 120, I get negative root 3 over 2. That is, okay, negative 0,866. So it's round about there, not necessarily accurate. And then negative 90, that's negative a half. And then at 60 we have 0. Negative 30 we have a half. At 0 we have 0,88866, whatever it was. 30 degrees, it's 1. 60 degrees, round about the same value. 90 degrees, it's a half. Okay, there we go. We have negative a half for 150, 180. There we go. And 210, we have negative 1. Okay, so we can join all of that up. And we have a nice graph. Okay, done. So now 6.3.3. Oh, this question went by quite a bit fast. So use the graphs to determine the values of x in the interval of negative 150 and 210, for which the y values of g are greater than the y values of f. Okay, so in this case, we are going to then look at the graph that we drew. Oh my word, what happened now? Okay, there we are. Okay, so where are the y values of g? By the way, this is g and that is f. So the y values of g that are bigger than the y values of f, it's basically in this region over here. Okay, you can see the graph of g is bigger, it's above. So now what we need to determine then is these points of intersections. What are those values? And I hope that you recognize that, let's see, that when we work out the general solution, we have negative 2 sine x. So if we take the 2 sine x to the other side, it will be negative. And we have cos x minus 30, which we just drew. So basically the values that we determined before, the negative 19,11 and the 160,89, that's definitely what we're dealing with here. So the intersection here would be negative 19,11 degrees, and over here it would be 160,89. And that helps us, okay? So the values of x, therefore, are in between negative 19,11 degrees and 160,89 degrees, okay? That is basically where the graph of g, the y values for the graph of g are bigger than the y values of the graph of f. And now b, it says if we have f prime, it's like getting the first derivative, okay? And if the derivative is equal to 0, that's basically where you have a stationary point, where your gradient is equal to 0. So we need to determine then from the graph where the gradient of the graph is equal to 0. Okay, but then there's that half x as well that you just need to consider. All right, let's go back to the graph. It has shifted, but it's all good. Let me just erase and let's see what we can do. Okay, so basically, so in the original graph, we can see that f of x is negative 2 sine x, okay? And the period here, okay, the coefficient of x is 1, meaning the period is 360, okay? And yeah, so the period is 360, but now what we're doing, we're putting half in front of the x, okay? And basically our turning point at the moment, so in our original graph, f of x, where we have a stationary point, it's at 90 degrees, okay? As soon as we put half in front of the x, it means that our period now is going to double, okay? So if you draw the whole graph, it will be one wave will occur over 720 degrees. But to note, our stationary point at this graph is at 90 degrees. Now, if we're going to double it by putting a half there to the period, our stationary point will now be at 180 degrees. Okay, so to answer the question then, where it says determine the value of x, where your stationary point, once you half your amplitude is equal to 0, that value of x will be at 180 degrees. I hope I am making sense. If not, please just comment down below and I'll try to explain in written words. But that concludes our question 6, and yeah, let's do question 7 later on. It says in the diagram below, P, Q, and T are 3 points in the same horizontal plane, and MT is a vertical mast. MP and MQ are 2 straight stay wires. The angle of elevation of M from Q is theta. PQ is K meters. PM is twice PQ. The area of triangle MPQ is 2K squared sine theta cos theta. What I love doing with these kinds of questions, I like breaking up the triangle so that I can see clearly what's going on. So what do I mean by breaking up the triangles? Well, firstly, I'm going to start with PMT. Okay, so we have PMT there, and we know MT is perpendicular to PT. Okay, and then I have another triangle as well. I'll start filling in the information that they have given us. It just helps me just to visualize and see what it is that I'm doing. So I have MTQ. Okay, there we have another triangle, and then I'm going to focus on the triangle at the base. Okay, that is horizontal basically, and that would be PQT. And I see that PT is perpendicular to QT. All right, so let's go fill in again what they said. All right, so we have the angle of elevation, so theta from Q to MT. So this is basically where theta is. And then PQ is K meters. PM, yes, I see PM, it's twice PQ, and we know that PQ is K, so PM is 2K. And the area of triangle MPQ, ooh, that's another triangle that I didn't actually draw out. So then we have MPQ. So basically the area there is equal to 2K squared sine theta cos theta. All right, now that I have all my triangles, I can go and confidently answer the questions. Now it says show that MPQ is 2 theta. What are they asking for? They're asking for angle P, that angle over there, angle P in MPQ. Okay, now let's just rehash again. So MP is 2K and PQ is K. Okay, that's perfect because I have 2 sides, all right, and I have an unknown angle over there. So I'm definitely going to use the cosine rule, all right? And, or should I? No, actually, I'm not going to use the cos rule because I don't have the angle, nor do I have the side. What I've been given is the area. So how about we use the area rule instead? Okay, so the area rule, okay, area of triangle, MPQ. Actually, area of triangle MPQ is equal to half, all right, MP times PQ times sine P. Sorry about that. All right, and yeah, so now we have the area. It's basically 2K squared sine theta cos theta is equal to half. MP is 2K and PQ is K and sine P. So we're basically looking for the P, right? Okay, so now we still have 2K squared sine theta cos theta is equal to, so the half and the 2 will cancel out, and the K squared I will divide by it, and then I'm left with sine P. All right, so again the K squared cancels out. So now I have 2 sine theta cos theta. I hope a bell or a light bulb is lighting on your side. So basically this 2 sine theta cos theta, it's basically the double angle of sine. So we have sine 2 theta is equal to sine p. Basically p then would be equal to 2 theta. And let's just write it the way they wanted us to write it. So MPQ is equal to 2 theta. Awesome. And we can go ahead and also put it there for ourselves so that we can know in the future that, by the way, this is 2 theta. All right, now we can go to 7.2. So it says, hence, show that MQ is equal to that. Now let's go back to that triangle. Now we can work out MQ. Now I can use the cosine rule. Okay, so basically the cosine rule, I will say MQ squared will be equal to MP squared plus PQ squared minus 2 times MP multiplied by PQ, and then cos P, which we just worked out. Okay, so let's just fill in what is missing. So I know that MP, okay, I'm going to need to go up and down. MP is 2K, PQ is K. So 2K squared, K squared minus 2, 2K, K, and cos 2 theta. Alright, so 2K squared, that is 4K squared plus K squared minus 4K squared cos 2 theta. And all the while, I need to keep looking at my answer just to see, am I getting closer to it? Okay, so basically now I have 5K squared. All right, 5K squared minus 4K squared cos 2 theta. Is this answer looking remotely close to what I'm supposed to be looking for? Well, at the moment it's not. So let's see how we're going to work that out. So this is now MQ. I'm going to start putting the square root over here. Now if I take K squared as a common factor, it's basically going to land outside there. Okay, and then I have 5 minus 4 cos 2 theta. All right, this is not looking at the moment like it should. Okay, so let's see. I don't have a cos 2 theta in my answer. I have a sine squared. So now I need to change this cos 2 theta to something that I am familiar with, as long as it has a sine squared in it. All right, so I'm going to go with the double angle for cos 2 theta, 1 minus 2 sine squared theta. Okay, I think this will work better. Now let's continue. I have 5 minus 4 plus 8. Okay, now things are starting to happen. Now I'm starting to look hopeful again. So 5 minus 4, that is 1. Okay, plus 8 sine squared theta. And is that, yes, that is looking like the answer. And we are done with 7.2. Okay, for a moment I was getting worried that we're not getting to the answer, but here we are. Okay, now it says if K is 139,5 meters and theta is 42, determine the length of MT. Okay, let's go see. We have MQ, right? Now they want MT. So I suppose, which triangle should we use? So I have MQ. They're looking for MT. Okay. And TQ, do we need it? Do we have it? No, doesn't matter. All right, so yeah, I think we can then use, sine theta in triangle MT. All right, so now we can say sine theta is equal to MT over MQ. Okay, and since we're looking for MT, we can then say sine theta all over, sine theta multiplied by MQ. And they've told us that theta is 42. So we can say sine 42 degrees multiplied by MQ, which we just determined in the previous question. It'll be 139,5 multiplied by the square root of 1 plus 8 sine squared theta, and our theta is 42 degrees. Okay, so it's nice we can put everything into the calculator and work it out. So we have sine 42 degrees multiplied by 139,5 multiplied by the square root of 1 plus 8 sine 42, and we're going to have to square all of that. Just be careful when you're dealing with sine squared or any of the trigonometric expressions squared, okay? And so we have 199,81 meters, but they said to the nearest meter, so it'll be 200 meters. Okay, and that is it for question 7. Question 8. In the diagram below, points P, Q, R, and S are points on a circle with center O. Alright, so we can see those points, P, Q, R, S. Alright, actually, yeah, it looks like a cyclic quad, but let's not look at it too much for now. And we have a center O. As soon as we have a center, I'm thinking to myself, is there a line from a center to a chord, or a line from a center to a tangent? It looks like we do have something. Do we also have a chord that goes not only to the center but to the circumference? I think if you were to put RZ there, yes, there's a chord that goes to the center, also goes to the circumference, so we can use our information there. Is there anything else? Like I said, a line from the center to the circumference, which is your radius, is perpendicular to your tangent line, but is XRY a tangent line? Let's continue reading. OT bisects chord QR at T. So you can see that RT is equal to TQ. XRY is a tangent. Yes, so it's a tangent, meaning we do have 90 degrees there. So tangent to the circle at point R, OZ is produced to meet at Y, where OY is parallel to QR. Okay, so we have two parallel lines there. What do we know about parallel lines? Are they alternating angles? I believe they are. Alright, so we know that R3 is equal to 20. Are they co-interior angles? Yes. So we can get a co-interior angle here. So you can get what Z is at that point. Or can we? But we don't know what R1 is, so that'll be a bit of a challenge. And are there any corresponding angles? not from what I'm seeing at the moment. Okay, anyway, moving right along. And then they tell us that O in ROY is 20 degrees, yes, and R in SRO is 10 degrees. We see it, and chord Z, S is drawn. Okay, now let's answer the questions then. Calculate with reasons the size the size of the following angles. So 8.1.1, S1. Okay, all right. So there we have S1 over there. Yeah, we did talk about it. So S1 will be equal to half, because S1 is the angle at the circumference, and you have from the same chord subtending an angle at the center. So S1 will be half angle of O1. All right, and O1 is 20 degrees. And what reason do we give? Well, basically, angle at the center is twice angle at circumference. Okay, so basically S1 is 10 degrees. I think let me just remove all of this and just put in what I know. Okay, so basically S1 is 10 degrees. And yeah, let's move along. 8.1.2. R3. So where is R3? There is R3. Great. We did talk about it as well. Remember, we have alternating angles over there. So basically R3 will be equal to 20 degrees. Okay. And what are we going to say? Well, basically we have alternating angles, and we need to state which angles are actually, or which sides are actually parallel. Okay, so we have alternating angles. All right, and basically we have OY parallel to QR. All right, and then 8.1.3. P, angle P. Let's just put in what we know here. So angle P, here is angle P. Oh, actually, remember when I said we have a cyclic quad? So basically this is our cyclic quad, right? Okay. No. What am I doing? Let's rather look at this cyclic quad over here. Okay, I think that's much better. So yes, we have a cyclic quad, and all points or all corners of that quadrilateral are on the circle's circumference. Okay, so yeah. So what do we know about cyclic quads? We know quite a few, but looking at where P is and what I also know over here, I know that P plus R2 as well as R3, that will be equal to 180 degrees. And why is that? Opposite angles in a cyclic quad are supplementary. Okay, supplementary meaning that when you add them up, they equal to 180 degrees. All right, so basically P is equal to 180 minus R2 plus R3. R2 is 20 degrees. R2 is 10 degrees. And R3 is 20 degrees. Okay, so basically P is equal to 150 degrees. Okay, this is where you score marks, guys. Question 8, please make sure you don't fumble it. Make sure you grab as many marks as you can. All right, and then now, so we know that P is 150 degrees. maybe let me just use blue. Let me be consistent. So we have 150. Now, 8.1.4, S2. Where is S2? Here is S2. Okay, I hope that you all saw that you actually have a triangle here. Remember, if you have a tangent line and there's a triangle, you can use the tan chord theorem. I don't know if it's going to work here, but let's see. But also the condition here is that the corners of your triangles should be also on the circumference. If they're not on the circumference, then you can't use this rule or this law. Okay, so or this theorem rather. 8.1.4 S2. What would S2 be equal to? S2 would be equal, if I were to use the tan chord theorem, S2 would be equal to R4. But do I have R4? I can get R4. I can definitely get R4. Remember we said angle, basically a line from the center to the circumference will be perpendicular to a tangent line. Okay, so basically R4 plus R3 should give you 90 degrees. So basically R4 is 90 minus 20 degrees, which is 70 degrees. And why is that? What's a simpler way of saying it? So radius is tangent, radius is perpendicular to tangent. Okay, tangent y rx, so x ry. Okay, so we have R4 is 70 degrees, and as such, R4 is equal to S2. Okay, which would be equal to 70 degrees. And why is that? Well, basically, you could just say the tan chord theorem. Okay, and yeah, wow, 4 marks. Very generous. But yeah, so anyway, now let's move on to 8.2. Prove that XRY is a tangent to the circle passing through RTO. Okay, let's just erase a few things over here so that we can see clearly and mark out all that needs to be. Let's just see. Okay, and let's go back to my favorite color there, which is blue. Yeah, so basically put everything that we know. All right, so now XRY is a tangent to the circle passing through RTO. Okay, let's use green to point out this RTO. So basically the circle passing through RTO, so it might look something like that. Okay, it's a weird circle, but I hope you get to see. Let me not even try to fix it. It's not going to be fixable. Let's just leave it like that. So that's basically the circle, okay? And we need to prove that XRY is a tangent to the circle. Okay, how are we going to do that? Well, I'm going to look for a triangle inside that circle. All right, and I see it. It is RTO. All right, and with this circle, if I can show that O2 is actually 70 degrees, then I'd be fine. I hope you see what I'm talking about. If we can just show that O2 is 70 degrees, then that would be great. Okay, using the tan chord theorem. All right, so that's what my hope is with all of this. Okay, now let us look deeply into this. Okay, first and foremost, I hope that you see, I'm thinking as we go along, we have a line from the center to a chord. I missed it the first time around. And we know that a line from the center to a chord is 90 degrees, or it's perpendicular to the chord. And we also know that it bisects the chord. This was given. That information was given. So we have basically 90 degrees over there. Okay? And if R3 is 20, T1 is 90 degrees, then O2 has to be 70. Okay, so how do we package this nicely? Okay, so firstly we're going to say that T1 is equal to 90 degrees. All right, and basically that's line from center to chord. Okay, perpendicular to chord. All right, so T1 is 90 degrees, and then we know that O2 plus T1 plus R3 is equal to 180, and that's basically sum of angles in a triangle. Okay, sum of angles in a triangle are equal to 180 degrees. So we know what O2, we're looking for O2, because we want to show that O2 is 70 degrees. So basically we have 180 minus T1, which is 90, minus R3, which is 20. Okay, so that's basically 70 degrees. And then O2 is equal to R4, which is equal to 70 degrees. All right, which is great. And therefore we can then conclude, therefore, that XRY is, so we can then say XRY is a tangent. Okay, and that's due to the 10-chord theorem. Okay. All right, it's sort of like the inverse, or the not the inverse, but the converse of the 10-chord theorem. Alrighty, and that is it with question 8. Question 9. In the diagram below, triangle ABC is constructed such that BC is produced to D. DR is drawn with point T on AC and R on BA. CS is drawn. So we have CT as 12 millimeters, TA as 36 millimeters, SR as 20 millimeters, and SA as 80 millimeters. All right. I do apologize for the background music. I do not have control over that. So let's just, try to ignore that and answer these questions that are following. So 9.1 says, prove that CS is parallel to TR. Where is CS? Okay, so let me just get a blue pen over there. So this is CS. We need to prove that it's parallel to TR. Okay, so how I'm going to attempt this, I'm going to look at triangle CTARS. Okay, and what I'm going to now do, it's sort of like a reverse of the proportionality theorem. Had they told you that CS is parallel to TR, and maybe you're looking for one of the sides or the lengths of the sides, you would use the proportionality theorem. So now I'm going to try to show that if I look at my triangle, so if I draw it upright, so this is 9.1. If I were to draw it upright, this is me now, trying to make sense of it all. And if I start with ARS, so this is ARS, and on the other end I have ATC. Okay, so I have that AT is 36, TC is 12, RS is 20. And since the whole length is 80, AR has to be 60 millimeters. Okay. So what I would then do to prove that CS is parallel to TR, I would look at the proportionality. Okay. What do I mean by that? I would say, okay, let's see if we have AR over RS and see what that amount is. And if we have a look at AT over TC, let's look at that amount, at that value. And if those two values are the same, then we can conclude, all right, that they are in proportion. And if they are in proportion, it means that CS would be parallel to TR. Okay, so now let's see, what is AR? It is 60 and RS is 20. So 60 divided by 20 is 3. And then if you look at AT, that is 36 over TC, which is 12. 36 divided by 12 is 3. Okay, which is great. So now we can see that AR actually over RS is equal to AT over TC. And if that's the case, then we can conclude that CS is parallel. CS is parallel to TR. All right, and why is that? So basically, the line divides the sides of a triangle in proportion. Okay, so yeah, let's just write that down. So basically, line, which line? RT. So the line divides the sides of a triangle in proportion. Alrighty, that's 9.1. And then we get to 9.2. Now it says, it is further given that AR is 2/3 of RB. So AR, there's AR, our 60 millimeters. That's actually 2/3 of RB. And BC is 2x. We have CD as half x plus 1. Now we need to calculate the value of x. Okay, so in this scenario, we've already proven that the two sides are parallel, right? I'm now going to focus on triangle DBR. Okay, I'm going to just draw it out for myself, upright. Okay, it makes things easy for me just to see things properly. If you're a little bit OCD and you just want things upright instead of having to turn your head many times, then this would help. Okay, so DC, we said it's a half x plus 1, and then CB is 2x. RS is 20, and we were told that AR is 2/3 of RB. Let's see. So 2/3 of RB. Because we kind of do need RB so that we can get SB. Okay, just write that out nicely. So that I can use the proportionality theorem and then we can solve. Alright, so now AR, I know it's 60. And then if I need RB, I'm just going to multiply it by 3 over 2. And let's see, what is 60 multiplied by 3 over 2? So 60 multiplied by 1.5, it is 90. So RB is equal to 90 millimeters. Now it means, therefore, that BS is 90 minus 20, which is equal to 70, not 70 degrees, but 70 millimeters. Okay, now that we have that out of the way, we can then use our proportionality theorem by saying BC over CD is equal to BS over SR. And it's basically the proportionality theorem. And we need to state which lines are actually parallel. CS parallel to DR. Alright, so what is BC? It is 2x. And CD is a half x plus 1. And then BS is 70. SR is 20. So now we're going to have to cross multiply and then solve for x. So 20 times 2x is equal to 70 times a half x plus 1. So we have 40x is equal to 35x plus 70. If I take 35x to the other side, I'll be left with 5x. And we have 70 over here. So what is 70 divided by 5? Well, I think it's 14. Yes, I'm just multiplying it in my head, but let's check. In an exam situation, we even calculate 1 plus 1 because our minds are occupied with a lot of things. So yes, it is 14, and we have the value of x, which is 14. All right, and that concludes question 9. Question 10. 10.1. Okay, so looks like we have a proof question here. In the diagram below, triangle ABC and triangle DF are drawn such that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Now prove the theorem which states that if two triangles are equiangular, then the corresponding sides are in proportion, right? That is, AB over DE is equal to AC over DF. All right, so we have covered a video on this, all the proofs that will be examinable for grade 12. So I'm tempted not to really do this again, but show you where you can get this proof and other proofs as well, because you need to know all of them because they could ask anything. So you go to our playlist and you're going to see the grade 12 mathematics lessons, right? And right at the end, you're going to see all examinable maths proofs for paper 1 and paper 2. And I do cover it, guys. Yeah.
What the?
Yes, what the? Yes, I do cover it. So I don't think I'm going to go through it again. But you know what? I think for the sake of completing this question, maybe I will. But basically, you can go to more and you'll see that I have timestamps as well. So we have the Euclidean triangle theorems. Just go straight there. Okay? And you will come across it. Yeah, so far it doesn't want to go there. Why? But yeah, basically I do cover the triangle, and I think it's the first one. Oh, this advert wants to play first. But yes, it is there. Please go have a look and you will be fine. All right. But so yeah, for those who are going to go to that video, you can stop it here. For those who are like, girl, just do the question. I will do it. Okay, it's fine. I will do it. Okay, so basically, how do we go about with this question? First of all, you online, or rather on the side of AB, you're going to put, or you're going to construct a line, okay? Let's say a line that will go horizontal, okay, up until that point. So you will put a point, let's just call it point M and N. And you must make sure that AM is actually equal to DE, all right? And then AN is actually equal to DF, okay, such that MN is equal to EF. Okay, so that's the first thing. Firstly, you're going to construct. So let me just say, because without this construction, you will not really get far, okay, and you will lose some marks, okay. So we're going to construct MN, all right, where M is basically going to be on the side of AB and N will be on the side of AC. All right, and as such, what you're going to then show and what you've already been given, okay, so once you have constructed that line, you can then confidently say that you have A, all right, which is going to be equal to D. And that was actually given. All right, and then we're going to go and say AM, okay, starting on the left. So AM is going to be equal to DE. Okay, so yes, and that's part of the construction that we just did. And again, AN will be equal to DF. Again, that is the construction that we did. Okay, and why is that? We're basically trying to show at the end that our triangle AMN is congruent. Congruent meaning it is identical. Okay, it's like a twin. It's, yes, an identical twin. So it's basically identical. So it's congruent. And congruency, we show it with these 3 horizontal parallel lines. Okay, so it's basically congruent to triangle DEF. All right, and we've shown it with 2 sides and an angle. So I would say side, angle, side. Okay, so firstly, the whole point, we want to start with constructing. Secondly, we want to show congruency. That is as a result of that construction. Okay, and now let's see. Now that we have shown that the 2 triangles are congruent, we can then say that angle M, right? Let's rather put it like this, AMN. Okay, angle M is actually equal to E because they're congruent, right? Yeah, okay, the music. Okay, throwback. And we can also show the triangle N, all right, we can say AN. No, let's remove that cap over there. So ANM, so angle N is actually equal to triangle, angle N is equal to angle F, all right? All right, yeah. So AN is equal to the X, which is F. Okay. Actually, we didn't even need to show that. What we can say with AMN, which is equal to E, we can also say that that is equal to B. All right. I hope you see that as well. And was it given to us? Yes, it was given that B is actually equal to E. All right. And if we have shown that angle M is equal to angle E, which is equal to angle B, we can then see that we actually have corresponding angles. Okay. So what we can then say, we have lines that are parallel. We can then say MN is parallel to BC. Okay, and that's because we have corresponding angles that are equal. All right. And same thing, I mean, N is equal to X, which is equal to F, which is equal to C. Okay, same story. Where you have MN parallel to BC and you have corresponding angles and blah, blah, blah. So now, are we concluding? Are we getting to the end? Are we almost there? Yes, we are. So now we can say AB over AM would actually be equal to AC all over AN. Okay? And then what reason would we give? We would say the line parallel to one side of the triangle. All right? And now we've also shown here that AM is equal to DE, remember? Because of the construction. So AM is equal to DE, and we can also say AN is equal to DF. We already talked about it with the construction. So at the end, we can then conclude coming here that AB over DE is equal to AC over DF, and we are done. Okay, and that is your 6 marks. These proofs are really not difficult. They're not impossible. But yeah, sometimes you can forget one thing and it's like, what is going on here? Or yeah, those 6 marks, you will labor for them, but ultimately they're really not that bad. But please have a look at that video with all the other proofs because you don't know what they're going to take out. Okay, and that is 10.1. Alright, 10.2. In the diagram below, diameter EMA of a circle with center M bisects FAB. Okay, so Emma, our diameter, there it is. So it bisects A, all right? And if we have a diameter as a chord, the angle it subtends is 90 degrees, right? So we know that F is 90 degrees while we're at it. All right, so now MD is perpendicular to the chord AB. So MD, perpendicular, yes. So a line from the center to a chord bisects the chord. Okay, and it's also perpendicular to the chord. So we know that AD is equal to BD. Okay, so on your exam paper, just write all these things down for yourself. Okay, and then we have AD that is equal to BD. Okay, the lengths. Yeah, what else do we know? Now ED produced meets the circle at C. Chords CB and FE are drawn. Alrighty. Yeah, I think that is it. But I don't know if we're going to need this at some point. But let's just say if we were to draw the chord EB, we would know that A2 is actually equal to C. Okay? Like I said, I don't know if we're going to need that. But it's always good just to note it. Or if you were to draw a chord on this side, then we know that E2 would be equal to B. Alright, like I said, I don't know if you're going to need it, but let's go through the questions. So it says in 10.2.1, prove that triangle AEF is similar to triangle AMD. So here we're not really given lengths per se, we're dealing more with angles. So if we're going to show similarity, I would rather we go the route of showing that the angles are equal. Okay, so we have triangle AEF. Okay, and we also have triangle AMD. Alright, so we're trying to show here that A is equal to A, that E is equal to M. See the way it's written down? That's the same sequence you're going to use. And we also need to show that F is equal to D. So let's see. Where is triangle? Let me use a different pen. Let's go with blue this time. Triangle AEF. Okay, so I see there's A, there's F, and there's E. So basically looking at this triangle over here. So there's triangle AEF. And now where is triangle AMD? There it is. So that's the green one. Okay, and I can see that F, which is 90 degrees, is equal to D1. All right, so I will then say F is equal to D1, which is equal to 90 degrees. But firstly, I needed to start with F. How do I know that F is equal to 90 degrees? So F is equal to 90 degrees. So if your chord is a diameter, angle subtended is equal to 90 degrees. Okay, and also D1 is equal to 90 degrees. Did they tell us? They said MD is perpendicular to AB. Yes, so D1 is equal to 90 degrees, and we know that line from center to chord we can say it was given. So line from center to chord is perpendicular to the chord. All right, and therefore F is equal to D, which is equal to 90 degrees. So we have one of the angles. Great. Now another angle is A1, which is equal to A2, and that was given, okay, because they told us that the diameter does bisect A. All right, and then E as well as M. So here's E and there's M. Well, we could just say sum of angles in a triangle because, yeah. Okay. So therefore we can conclude, how many marks is this? 4 marks. So therefore we can conclude that triangle AEF is similar to triangle AMD. Now we can move on to the next question. Now it says determine the numerical value of AF over AD. Okay, so now that we have shown that triangle AEF is similar to triangle AMD, we can then say that AE over AM is equal to EF over MD, which is equal, remember AE there, and then we have EF and MD, and then finally we have AF over AD, which is what we're trying to show, and that is 3 marks. So what would be the numerical value of it? Where do we start? Do we have any length at this point in time? What I do know, let me just use a different colored pen, is that we have a diameter, right? And AM, now we can't see what's what. So this is the radius, and that's the radius. Okay? And yeah, let's see, what can we do then with AF? Okay. What can I do with EF maybe? Nothing with EF. AF, no. EF, AE. If I were to say AE over AM, yes. So AE over AM is equal to AF over AD. And why I'm choosing AE is because that is where our diameter spans. And AE would be twice the radius, right? It's the diameter. So 2R. And AM is just R. Okay? And then we have AF over AD. So now we can show that AF over AD is actually equal to 2. And that is the numerical value. All right. So yeah, that is basically that. And then 10.2.3, we're almost there. We're almost there. This paper didn't seem so bad. Now it says, prove that AD squared is equal to CD times DE. Okay, AD squared. I think I'm going to have to erase a lot of things here because I have hidden AD. And then let's just have a look. Let's just erase certain things so that we can see clearly what's going on. Okay, just erase everything and see what we can do here. So AD, let's just highlight that. CD, there's also CD, and DE. Okay, so there's CD and DE. What do all of these things have in common? Ah, my word. Okay, so we have AD squared. Okay, we have this. But so what? I'm trying to see which two triangles are actually similar, so that I can use them. So this is still my radii. Okay. Yeah, I think I will have to maybe try to use this triangle because I don't know where I can place CD. Okay, so let's have a look at triangle ADE and triangle CDB. But I don't know if what I've written is in the correct order. Okay, all right, so what I can then do, I know I've erased this, but if I have a chord over here, I know that A2 is equal to C. Okay, so I can then say A2 is equal to C, and that's basically angles subtended by the same chord. Okay, and then I know that D1 and D2 are equal to D4. Okay, and that's basically vertically opposite angles. Just use that, vertically opposite angles. And then the remaining, well, they'll just be equal to one another. But if you wanted to really show that, you could have also drawn that chord, which I did at the beginning of the question. And I said E2 is equal to B. Okay. E2 is equal to B. Same thing, angles subtended by the same chord. Or you could also say angles in same segment. Both apply. Okay. So did I write them in the right order? So yes, A is equal to C, D is equal to D, and then E is equal to B. Okay, great. Yeah, so if they are in that order, now I can then say triangle ADE is similar to triangle CDB. Okay, and as such, I can then say AD over CD is equal to DE over DB, which is equal to AE over CB. And now I need to look at my answer. There's an AD here. So yes, I'm going to use this portion. There's a CD and there's a DE. Okay, so I'm going to go with this. All right. I don't think I have to focus on AE or CB. So then I can say AD over CD is equal to DE over DB. All right, and I am going to cross multiply. So AD times DB is equal to CD times DE. So I have this portion, all right? Now I just need to show that DB is actually equal to AD. Where is DB again? This is DB. So how do I show that DB is actually equal to AD? Oh, so we were told that AD is actually, I actually wrote it here. AD is equal to BD, right? Or DB. Let's just write it as DB rather. So AD is equal to DB. And why is that? So the line from the center to the chord bisects the chord. Okay, so therefore I have AD times AD is equal to CD times DE. And therefore we have AD squared is equal to CD times DE. And I believe we are done. We are done, ladies and gents. See you on the physics side.